Hey, welcome to Draft Academy. My name is Mike. This video is part of a series of videos where I'll be going over the basic syntax of different programming languages. Now, one of the most annoying things about picking up a new programming language is having to learn all the syntax from scratch. In my own experience, it generally manifests in a lot of Google searching and Stack Overflow. For an experienced developer, the problem isn't understanding the concepts of programming, it's knowing how to implement those concepts in the new language. So things like variables, data types, data structures, loops, conditionals, and object orientation. All of these things are done a little bit differently in each programming language, and having to research how to do it all can be extremely annoying and tedious. In this video, I'll go through and show you the basic syntax for the most common parts of the language. I'll give you a brief history of the language, and we'll touch on some of the best practices and conventions used in that language. Now, this is meant to be a quick run through. I won't be showing you how to install or configure anything, and we won't really have time to learn how to do everything. You see, I've distilled it down into what I consider the core concepts. So the goal for this is to be a quick video, so I can't cover every aspect of the language. With that being said, this video is meant for programmers who already understand the core concepts of programming. It's not going to teach you any programming concepts. I'll simply show you how to do all the common things in the new language. So if you are new to programming, Draft Academy has hundreds of videos where I hold your hand and I walk you through everything you need to learn to program, but this is meant for developers who already understand programming. So without further ado, let's get started. C++ is a general-purpose, statically typed, object-oriented programming language that began in 1979 by Danish computer scientist Bjørn Strostrup. For several years, the language evolved until its official release in 1985. C++ is essentially an extension of the C programming language. It actually began as a fork of an early pre-standardized C, and while C is not a strict subset of C++, the two languages are largely compatible, and in many instances, C code can be used with little or no modification as C++ code. Because C++ is an extension of C, many of the things you can do in C, you can also do in C++. But in addition, C++ gives you all the power and flexibility of object orientation. So you can use low-level system calls, manage memory, and deal with pointers, while at the same time working with classes, objects, inheritance, and all the features of an object-oriented language. So C++ really lives in two worlds. All C++ programs must utilize a compiler whose job is to compile the C++ code down into machine code, which is readable by the computer. So anytime you want to run a C++ program, you have to compile it first. C++ relies on the user to manage the program's memory, although there are garbage collectors available for C++. Many developers choose to write C++ using a basic text editor, but there are also more specialized integrated development environments. Some of the most popular are CodeBlocks, Eclipse, and NetBeans, and also Microsoft's Visual Studio. So what I want to do is just give you guys a full overview of the basic C++ syntax. We'll look at all the different things you can do in the language and how you can do them, and hopefully this will just be a great introduction into this language. So you'll notice over here I just have a basic C++ program set up. This is kind of like the skeleton for a program. Up here I have a couple include statements, and generally these are going to allow you to work with things like strings. And also this IO stream will allow you to print out and get information from the user. And then down here I'm saying using namespace std, and this stands for standard, so it's just a standard namespace. And if you put this up here, it'll make your life a lot easier because we won't have to prefix all of our C++ method calls and things like that with std. So just put this up here and then you'll be able to follow along with everything that I'm doing. And then down here we have this main function, and this function is basically what's going to get executed when we run our C++ program. So any code that I put inside of here is going to get executed when I run the program. So I'm going to be executing my code over here in the command line, and that way you guys will be able to see the code, and then you'll be able to see what the result of executing the code is. First thing we'll look at is printing, and the way that we can print is by using this cout command, and cout just stands for like console out. And basically I can say cout and then two less than signs, and then basically it'll print out whatever I put over here. And then I can also make 2 more less than signs and put end L. Now end L is a special command that we can use, and this will basically just print out a new line. So you'll see over here I'm printing out a new line. Down here I'm not, I'm just ending it off, and then down here I am. So you'll see over here when I execute this code that we're printing out hello world and then an exclamation point. So depending on whether or not I use end L, it's going to do different things, but you can use these less than signs to basically print out different things. So now let's talk about variables. So variable, the names are case sensitive and they can begin with letters or an underscore. And after the first character, you can have letters, numbers, or an underscore. And convention says to start with a lowercase word and then additional words are capitalized. So this is the same rules as the C programming language. So if I had a variable like my first variable, I would name it just like that. A lot of people will call that like camel case. And because C++ is statically typed, we have to rigorously define the types of each of our variables. So over here I have a string, and a string isn't actually a primitive, it's not a built-in type. And you'll see up here I'm including string like that. That'll allow me to use the string, although a lot of compilers will just go ahead and include that for you automatically, so you don't necessarily have to put it up there. So I can create a string with these open and closed quotation marks and a string of characters. Again, it's not primitive. Then we have a character, and you're going to delineate it using these single quotes, and that's a simple 8-bit character. And down here we have integers. So integers are going to be whole numbers, and there's a bunch of different types. First is a short, and that's at least 16 bits signed integer. And then we have the int, which is just like the default, and that's going to be at least 16 bits signed integer, but it's going to be not smaller than a short. Then we have a long, which is at least 32 bits signed integer, and then a long, which is at least 64 bits signed integer. And you can make any of these unsigned by using the unsigned prefix. So I could say like unsigned int, and now this is going to be unsigned instead of being signed. And then down here we have our floating points. So these are going to be decimal numbers. So I can have a float, and you'll see over here when I create the float, I put an F after it, and that's just a single precision floating point. Then we have a double, which is going to be a double precision floating point, and then a long double, which is an extended precision floating point. So depending on the amount of decimal places that you need to take these two, you can use different ones. Double is going to be the default though. And finally, we have a 1-bit Boolean. So this is going to be a true or a false value. And you can see I don't have to give this a value right away. I could just declare the variable, and then down here I can give it a value. You can also modify the values of variables just by referring to the name and setting it equal to something different. And then if I wanted to print out a variable, I could use this cout statement. So I can say cout, again, less than, I could type in like a string, and then in here I could just weave in the variable just like that. And then you'll see over here we're printing it out. So that's probably the most common way to do this in C++. So next I want to talk to you guys about constants, and a constant is basically a special type of variable that can't be modified. So anytime that we're using constants in C++, we can just use this const keyword. So I could say int const birth year. In this case, I'm defining someone's birth year. And generally, as a convention, whenever we're naming constants, you always want to name them as uppercase. So everything's in uppercase, and words are separated by this underscore. Also, if you wanted, you could put the const over there, like behind it, and that's going to be just as fine as well. What you can't do with these, though, is you can't modify them. So like I said, birth year is equal to 1988. We couldn't actually do that because it's a constant, so we're not going to be able to modify it. So now let's talk about casting. So with casting, we can convert data types into different data types. So for example, down here I have a double, and if I can cast it into an integer. So it'll basically take this double and put it into an integer. And then I can do the same thing for an integer. So I have this integer 3. I could cast it to a double. So now it'll be 3.0. I can divide 3.0 by 2, and we'll get 1.5. So you can see over here is the result of doing those casts. So since we're on the topic of data types and variables, I want to talk to you guys about pointers. Now, a pointer is basically just a type of information that we can represent in our C++ programs. It's basically a memory address. So we can work with and access different memory addresses using C++. And actually, this is kind of taken from the C programming language, which, like I said, C++ is a fork of the C programming language. So a pointer is basically just a memory address. So for example, I have down here int num is equal to 10. So I have this number integer. What I can do is I can print out the memory address of that integer just by using this ampersand. So if I prefix the variable name with an ampersand, this is going to give me the memory address where it's stored. So over here you'll see we have that memory address. And that's a hexadecimal number. And then over here, if I wanted, I could take those memory addresses and I could store them inside of a variable. So again, memory addresses, we would just refer to them as pointers in C++. And just like you can store an int or a double inside of a variable, you could store a pointer inside of a variable. The way that I do that is just by specifying the name of the data type. And then if I want to make a pointer, I need this asterisk and then type in the name of the pointer variable. And then over here, I can store the pointer. So I can store the memory address, which again is accessed using this ampersand. And because I'm storing the memory address of an integer, like up here, num is an integer, I need to put an integer over here. Then what I could do is I could print out pnum. So over here, you'll see that I'm printing out that memory address again. And then we can also do something called dereferencing a pointer, which is basically going to go to that memory address and grab the actual value. So I can dereference a pointer by using this asterisk, and that'll dereference pnum, and then it's going to get 10. So we're getting the value that's stored at that memory address. Now I want to talk to you guys about strings. So a string is one of the most common data types that you're going to be working with in C++. There's a lot of information that can be represented using strings. So like I said before, whenever we want to use strings, technically you need to use this include statement, so include string. I had that up there at the top of the file, but a lot of compilers will automatically include that for you. So in a lot of cases, it's not super necessary that you put that in there, but just to be fully correct, you're going to want to include that. And down here, I have a string greeting, and the indexes with strings start at 0. So I would say that this H character is at index position 0 all the way up to 4. So even though hello has 5 characters, the last character is at index position 4 because we're starting the counting at 0. That's pretty standard across all programming languages. Now down here, I'm just printing out some different functions or attributes about the string. So I can say greeting.length, open and close parentheses, and that will give me the length. So actually, if I put end L here, it'll be a little bit easier to see. And you can see over here, we're getting 5, so that's how many characters are there. You can also access specific characters inside of the string. So I could say like greeting, open and close square brackets, and then the index. So if I say greeting, open and close square bracket 0, it gives me this H because that's the first character. I could also check to see if a substring is inside the string. So I could say greeting.find LLO. And this is going to tell me whether or not LLO is in the string. And if it is, it'll give me the index. So this gives me a 2 because LLO starts at index position 2. We can also get a substring. So I could say greeting.substr. It stands for substring. And if I put a 2 here, it'll basically grab all the characters starting at index position 2 going to the end. So it starts at 2, which is this L, and it grabs all the way to the end, which you can see here. You can also pass in 2 arguments. So I could pass in like 1, and this is going to be the starting index. And I could pass in a 3, and that's going to be the length. So it'll start at 1, it'll start at this E, and it'll grab 1, 2, 3 characters. So we grab ELL, and you can see we grab that over there. There's a bunch more of these string functions, and if you just Google C++ string functions, then you'll find a full list of them. But that's kind of just an introduction into some of the most common ones. In addition to representing strings in plain text, we can also represent numbers. So a lot of times you're going to want to be working with numbers in your C++ programs. So down here, I'm just showing you guys some basic operations that we can do on numbers. So I can say like 2 times 3, and that'll give me the result of that multiplication. You can also do addition, subtraction, division, and multiplication. So all the basic math operations. You can also use the modulus operator. So the modulus operator will divide 2 numbers and return the remainder. So if I said like 10 mod 3, this will divide 10 by 3, so 3, and it'll give me the remainder, which is 1. So that's why we get a 1 over here. If you want, you can also specify order of operations. So down here, I have this little math equation. So it's 1 plus 2 times 3. By default, C++ will do the multiplication first. So it'll say 3 times 2, which is 6, plus 1. And then we'll get 7. But if I wanted to do the addition first, I could just surround it in parentheses like that. And now when I run the program, we're going to go ahead and get 9 because now it's doing 1 plus 2 is 3 times 3 is 9. I also want to show you guys how integers and doubles interact, so how whole numbers and decimal numbers interact. So if I have a whole number and I do a math operation on it with a decimal number like that, we're going to get a decimal number back. So if I do 10 divided by 3.0, we get 3.3 repeated. But if I was to make this an integer, so now this is no longer a double. Now we're just going to get 3 back because when you do math operations on 2 integers, you get an integer back. When you do math operations on 2 floating points, you get a floating point back. Or if you do a math operation on an integer and a floating point, you get a floating point back. And down here, there's a couple other things we can do. So I have this integer called num. I gave it a value of 10. I can say num plus equals 100. And what this will do is it'll add 100 to the value stored inside of num. and it'll set num equal to that value. So now when we print out num, you'll see it's equal to 110 because we added 100 to 10, and num now has the value of 110. You can also increment, so I could say num plus plus, and what this will do is it will print out num with 1 added to it. So plus plus increments. You could also do minus minus, which would decrement. So now we get 111 over here. There's also a bunch of different useful math functions that you can use in C++. So what you can do is just Google like C++ math functions. You can get access to, square root, power, logarithmic stuff, sine, cosine, tangent stuff, all that, standard math function stuff you can get just by, like I said, looking up a library that will give you access to that. All right, so now let's talk about getting user input, specifically getting input from just like the console. So this is like the most basic form of getting input. What we can do is we can actually use a specific C++ function called cin. So over here, you'll notice that I'm just creating a string called name, and then I'm saying cout, enter your name. So I'm prompting the user to enter information. You can see that's what's happening over here. Then I can use this cin function. And what this is going to do is it's basically going to allow the user to input information. So it'll pause the execution of the program and wait for the user to enter something. And I can store whatever they entered inside of this name variable. So here I'm just passing that string name. And then over here, I can just cout hello name. So if I was to come over here and enter my name, Mike, now when I hit enter, it says hello, Mike. I also have this other one down here. This is going to demonstrate how to get numbers from the user. So I have two integers, num1 and num2. And again, I'm just printing out a prompt, enter the first num. You can see that's over here. And then I can cin for num1. And what this will do now is it'll take whatever the user enters and store it inside of this num1 variable, which is an integer. So it'll store it as an integer. And I'm doing the same thing for a second number, and then I'm just adding them together. So I could enter in over here like a 10, and I can enter in a 20, and now you'll see I'm getting 30. So it's getting that input as an integer, and it's able to add those two integers together. No programming language course would be complete without arrays, so I'm going to show you guys how to use arrays. The first thing we have to do when we create an array is declare the type of information that we want to store inside the array. So this is similar to making a variable, so I'm just going to make an int. I'm giving it a name, lucky numbers, and then you need this open and close square bracket after the variable name. Then I can set it equal to some value. So inside of these open and close curly brackets, I can specify different array elements. So you'll see over here, the elements start at 0. So when we index these elements, this first element, element 4, would technically be at index position 0, 8 would be at 1, 15 at 2, etc. So just like strings, we start indexing at 0. If I wanted to access a specific element inside of the array, I could just access it like this. So referring to the name of the array, inside of square brackets, the index of the element that I want to access. So in this case, I'm accessing 0, which is going to be this 4. I'm setting it equal to 90. So down here, if I print out lucky number 0, it's going to be 90 since I modified it. And if I print out lucky numbers 1, it's going to be this 8 over here. You can also create arrays a little bit differently. So in this case, I knew what values I wanted to put in here initially. But if you don't know that, you can just specify the array like this and not give it any information. All I have to do here is just specify how many elements I want the array to be able to store. That way C++ can allocate the appropriate amount of memory. So if I just say int lucky numbers 6, now this array will be able to hold 6 integers. I can say lucky numbers 0, and for example, I could assign this the value of 90. So now I could technically just assign each of these values individually, and I wouldn't have to populate the array up front. You could also represent n-dimensional arrays. So these would be like a 2-dimensional or a 3 or 4-dimensional array. Here I just have an example of a 2-dimensional array, which is pretty common. So it's the same thing as the other array, just int number grid, I'm calling it this time. And over here, I'm specifying like the number of rows and the number of columns. And then I'm giving this some initial information. So here I have like my overall array inside of these open and close curly brackets, but then I have 2 individual arrays as elements. So the first element is an array, and the second element is also an array, and each of these arrays have 3 elements, and that's reflected over here. So this is basically saying that I have 2 elements inside of here, and each of those array elements is going to have 3 elements, and you can access them just like this. So 0, 1 is actually going to refer to the 0th array, and then the first element in that array, so it's going to be that 2. And so down here, I'm printing out 0, 0, and 0, 1, so I'm printing out 1, which is going to be this element, and then 0, 1, which I modified to be 99, so it's going to be 99. And that basic structure will carry forward for n-dimensional arrays. So if you want to have like 3 or 4 or 5-dimensional arrays, it's going to be essentially the same concept. You can also, if you don't know what information you want up front, just declare it like this. So you could just say number grid 2, 3, and then again, you could just populate those as you go, maybe like from a looping structure or something like that. All right, now I want to talk to you guys about another type of array. It's actually called a vector, and vectors are essentially just dynamic arrays. So it's an array that allows us to do special things. So I don't have to, define how big this array is going to be up front. With a vector, you can just kind of populate it as you go. You can use all sorts of methods on it, like push, pop, and stuff like that. So over here, if we want to use these vectors, you need to include it. So I'm just doing hashtag include greater than less than vector, and that'll allow us to use it. I can create a vector just by saying vector, and then inside of these open and closed greater than less than, we can define what type of data we want to store inside. So in our case, it's going to be strings, and I'm just calling this friends. And if I want, I can add elements to this friends vector. So I can just say friends.pushback, and that'll just push an element into the vector. So you can see I'm pushing Oscar, Angela, and Kevin. And if you want, you can also insert an element at a specific position. So I could say friends.insert. And over here, you always need to say friends.begin, and that's basically just going to be like a pointer to the beginning of the array. And then I could say friends.begin plus 1, so that'll insert it at index position 1. And so at index position 1, I'm going to insert the friend Jim. And down here, you'll see I'm printing this stuff out. So I have like friends.at0. So 0 is going to be Oscar, which we get up here. And then I'm printing out friends.at1, which again, we put Jim here. So now Jim's going to be at index position 1. And then friends.at2 is going to be Angela. And if we printed out friends.at3, it would be Kevin. And also I can print out the size, which is 4. And if you want, you can also erase a friend. So I could say like friends.erase. And again, in here, you just want to put an index position. So I'm going to start with friends.begin, and then I'm going to add 1 to it. So now this is going to erase the friend at index position 1. So it's actually going to erase Jim. And now when I run this program again, you'll see that it's Oscar, Angela, Kevin, so Jim is completely gone. So that's how we could erase a friend from the vector. And like I said, vectors are just more useful. It's a more dynamic structure than just a static array where you have to like rigorously define how many elements you want to hold inside of it. Now I want to talk to you guys about functions. A function is basically just a container where we can store reusable code, and then we can call it throughout our program. If I want to create a function in C++, it's really easy. I have one up here. You'll notice that we have our main function, which again, this is the function that gets executed when we run our C++ file. But when I want to create a new one, I can just go outside of here, and I'm going to go above it, and I can just, first thing is specify a return type. So you can also say void if you don't want to return anything, or you can specify any one of those data types. And then we give it a name. I'm calling this add numbers, and I'm taking 2 parameters, so an int num1 and then an int num2, and then down here I'm just returning num1 plus num2. So this return keyword will break you out of the function, although if you put void here, you don't need that return keyword. You can just kind of run the function. And then down here, I'm saying int sum, so I'm making an integer called sum, and I'm setting it equal to the result of adding 4 and 60. So over here, you'll see we get 64 when we print out sum. So this function is returning the value of adding those 2 numbers. So over here, I'm putting this function up above this main function. But if I was to put this below here, now what I have to do is I need to put a method stub up above. So the main method isn't going to know anything about the add numbers method if I declare it below here. So if I do that, I need to basically just specify the method signature up above the main method. And now I should be able to use it no problem. But if I was to get rid of this, then I would actually get a compiler error over here. Now let's take a look at conditionals. So if statements allow us to respond to different things in our programs and essentially just make decisions. So up here I have 2 Boolean variables, is student and is smart, and they're both equal to false. So what I could do is I could have my program respond to those variables using this if-else block. So I can say if, and I'm basically checking 2 conditions. So I can use this and to check 2 conditions, or I could also use or like that, which is just gonna be 2 bars. So I'm saying if is student and is smart, and then if both of these are true, then we'll execute this code down here. I can also use an else if. So again, now I'm checking if is student, and I can use this negation operator, which is that exclamation point, and that'll just negate the condition that's next to it. So if I say exclamation point is smart, it's basically saying if they are a student and they're not smart. And then also I just have this else down here, which is pretty self-explanatory. That'll just execute if neither of these conditions is true. So that's how we can do that using Booleans. You can also obtain Boolean conditions by using comparisons. So I can compare like if 1 is greater than 3. So obviously this is false, but if I was to make this less than, now when I run this program, you'll see that that was true, and it says the number comparison was true. It looks like I had a typo here. So the comparison operators are useful. You have greater than, less than, greater than equal to, less than equal to, not equal to, and double equals, which is going to be equal to. You can also check to see if characters are equal to each other. So I could say like 2 characters are equal or even greater than or less than. And then if I wanted, I could do the same thing with strings. So I can create a string like my string, set it equal to cat. And I can use this method down here, myString.compare cat. So this is going to compare it to cat. And if I say not equal to 0, that'll check to see that it's not true. But if I said equals, this will basically check to see if this string is equal to cat, which now when we run our program, you'll see it says string comparison was true. So that's how you can compare strings. You can also compare primitive data types like characters and numbers, or you can just use straight up Booleans as your conditions, and that's going to work as well. All right, now we'll look at another type of conditional, which is a switch statement. A switch statement is essentially just a special type of if statement where we're comparing one value to a bunch of different values. So over here, I have a character, my grade, and it's just equal to A. And what I can do is I can make a switch statement, and inside of this switch statement, I can pass in that variable my grade. And now what we can do is we can check that my grade variable against a bunch of different cases. So I could say like in the case that my grade is equal to A, I can just see out you pass. So you can see over here, since my grade is equal to A, we pass. If I set this equal to F, now this case over here is going to be true. So it'll say you fail. And then this default's going to cover every other situation. So if none of these cases match up, so if I put like a Z here, now it's going to say that it's an invalid grade because we executed this default. So also you need these break statements here on these cases so you can break out of the switch statement. Otherwise, you'll just keep executing through the switch statement even after one of the cases matched. Now we'll move on to looping. Looping is a staple in any programming language. And C++ has a while loop. It's a very basic standard loop. Essentially just going to loop through while a certain condition is true. Over here I have an integer index. I set it equal to 1. And while index is less than or equal to 5, so as long as that condition's true, we're going to keep looping through. And you'll see over here, I just print out index, and you can see I'm printing it out over here. And then I'm incrementing index, so index plus plus. So that loop's going to keep looping until this condition's false. And one thing you want to watch out for is infinite loops. So if I was to get rid of this index plus plus, now this is going to end up being an infinite loop because this condition up here will never be false. In addition to a while loop, we can also define a do-while loop. So a do-while loop is pretty similar. The only difference is that in a do-while loop, you execute the loop body and then you check the condition. So even if I had index up here equal to 6, I'll still be able to execute one iteration of this do-while loop because it executes the code before it checks the condition. Whereas in a normal while loop, it checks the condition and then it executes the code. In addition to a while loop, we can also use a for loop. A for loop it's essentially a while loop, but it's just a lot more convenient. And a for loop will allow us to keep track of a variable as we go through the structure. So over here inside of this for loops parentheses, I can specify 3 things. First thing is a variable, so I can instantiate a variable. So I'm just saying int I is equal to 0. And then over here, we have our loop guard, which is the loop condition. So I'm going to keep looping as long as I is less than 5. And then over here, this is a line of code that'll get executed after every iteration of the loop. So I'm just incrementing I, and then down here, you can see I'm just printing it out. So starting at 0, we go through the loop 5 times, printing out 0 through 4. And again, we're going to loop as long as this condition over here is true. So that's a for loop, and that'll allow you to keep track of, like I said, a variable as you go through the loop. All right, so now let's talk about exception catching. So a lot of times in your C++ programs, certain circumstances will arrive which will throw exceptions, thus terminating the execution of your program. And in a lot of cases, you're going to want to be able to handle those and allow your program to keep executing. So down here, we can do basic exception catching. I can use try catch blocks. So I can say try and then open and close curly bracket. And inside of here, I can put any code that might break my program. So let's say I wanted to enforce a rule where you can't divide numbers by 0. So down here inside of this try block, I have this division function. And then up here, I defined the division function. Basically takes in 2 parameters. And if b is equal to 0, so in other words, if you're trying to divide a number by 0, then over here I'm throwing an exception. So basically it's saying division by 0, error, or I guess I could say exception. But basically you can throw an exception which will, result in your program terminating, and that's essentially just like something went wrong. But otherwise this division function will just return a divided by b. So in this case I'm trying to divide 10 by 0, which can't happen. So this division function is going to throw an exception, which this try block will catch, and then down here in the catch block, again, you can just pass this a parameter. So we can just define a parameter like this. I'm calling it message. And down here, this will print out whatever message got thrown. So when I run my program, you see it prints out division by 0 error. So that's basically how you can catch exceptions in C++. All right, so now let's talk about object orientation. C++ is great because it's an object-oriented programming language. We can do a lot of object-oriented programming stuff inside of it. So up here, I actually created a class, and I can create this class right alongside this main function. Or what a lot of people will do is they'll put classes inside of their own files. But for our case, this is just easier to see. So I have class book, and what you can do is you can define some public attributes. So public basically means that all the stuff down here is going to be accessible to all the other code in my program. And later we'll talk about private, which is kind of the opposite. So public, and then inside of here, I can define some attributes. So I can say like string title, string author, right? Those are two things you might define about a book. And then down here, I can define a function read book. And you'll see this read book function is basically just printing out reading this title by this author. And when I use this keyword and then I make this little arrow, what that's doing is it's going to access the title or the author for the object, for the specific object that's calling this read book function. So I might have like a couple objects in my program, and if each of them call this, it'll access a different title and a different author, and you'll see that in a second. So down here, I can just say book one, and this will allow me to create a book object, and then I can assign the book object certain attributes. So I could say like book1.title is Harry Potter, book1.author is J.K. Rowling. And then if I wanted, I could come down here and execute that function. So I could say like book1.readBook. And over here it says reading Harry Potter by J.K. Rowling. So because I set the title and the author, when this read book function up here said this arrow title, it accessed Harry Potter and then it accessed J.K. Rowling because I was calling that function on this book1 object. And then also if I wanted, I could just print out like the title. So I could say book1.title and that'll give me Harry Potter. So that's sort of basic classes and objects and how they work. All right, now I want to talk to you guys about constructors. So a constructor is a special function which gets called when you create an instance of a class. So whenever I create a book object, for example, the constructor will get called. And I can use that constructor to assign initial values to the object. So up here in my book class, I added this book constructor. And you basically create it just by saying the name of the class, and then again, you can put over here some parameters. And you can define multiple constructors. In this case, I just have one. But this constructor is going to take in a title and an author. And then over here, I can say this title and this author is equal to the title that got passed in and the author that got passed in. So that's pretty standard constructor stuff. And then down here, when I create an instance of the book class, when I create a book object, I can just say book1, and then inside of parentheses here, I can just pass in the title and the author. And that makes it a lot easier for us to create these objects. And then down here, I can just print out like book1.title, and we're printing out Harry Potter. So instead of having to individually assign book title and book author, I can do it using the constructor. Another thing we can do is create getters and setters. So a lot of times in C++, when you're building classes, you're going to want to control the access to the attributes of those classes, and you can use getters and setters. So I have an example of that up here. Now you'll notice over here I have this private keyword and then a colon, and then down below here I just have string title and string author. Basically, when I use that private keyword, what that means is that anything under here is set to private. So that means that only code inside of the book class can access the title and the author. So if I was outside of the book class, I wouldn't be able to access the title and the author because these are under this private block. And then over here, because these are private, I can't access them down here, like if I was going to create a object. So what I can do is I can create accessors. So I can create a get title method and a set title method. And the get title method just returns the title, and the set title method just sets the title. I can do the same for the author. And then over here in the constructor, when I'm setting them, I'm using those setter methods as well. So that's basically how you can use getters and setters. And then over here, I could say like book1.getTitle. So I can't access the title directly anymore. I have to go through the getter. And if I wanted to set it, I'd have to go through the setter. So that's how you can tighten up your classes with getters and setters. All right, now I want to show you guys inheritance. So inheritance is a special thing we can do in object-oriented programming where a class can actually inherit functionality and attributes from another class. So up here, I have two classes that I created. I have this chef class. So over here, it just says class chef. And this chef class has 3 public functions. It has a make chicken function, has a make salad function, and a make special dish function. And it basically just, prints out what the chef is doing. And then down here, I have another class, this Italian chef class. And this Italian chef class actually is inheriting from the chef class. So over here, I just have this colon, and then I say public, and then the name of the class that I want to inherit from. So down here, the Italian chef, I actually gave it another function, which is make pasta. So the Italian chef can make pasta, and the Italian chef is also overriding the make special dish function from its superclass, which is that chef. So down here, I have an example. I'm creating a chef object, and I'm saying my chef.make chicken. So the chef is going to make chicken, but then the Italian chef over here, I'm creating one down here, can also make chicken. So both of these can make chicken. Even though the Italian chef didn't define a make chicken function inside of here, because it's inheriting from the chef class, it's able to make chicken. And then also I overrode the special dish function. So if I said my chef.make special dish, and then I made the Italian chef make the special dish, and I ran the program, these are both going to make different special dishes. So the chef is just making a special dish, and the Italian chef is making chicken parm because I overrode it. So that's basically how we can use inheritance in C++. There's another thing I want to talk to you guys about with inheritance, which is using constructors in subclasses and superclasses. So over here in the chef class, you'll notice that I actually have 2 attributes now. So I have a name, and I also have age. And then down here, I have my constructor, or my initialize function. And basically, it's taking in the name and the age, and it's setting both of them. So the chef class and chef objects can have a name, and they can also have an age. Down here in the Italian chef class, which again is inheriting from the chef class, I added another attribute, which is country of origin. So down here, I have my own constructor for the Italian chef class. You'll see over here how this constructor is set up. So it's just Italian chef. It's taking in a name, an age, and also a country of origin. And over here, what I'm doing is I'm saying colon chef. And basically what this is doing is it's calling the constructor for the superclass. So this is calling the constructor that was defined up in the chef class or the superclass, and I'm passing in name and age. So what this is going to do is it's going to take care of setting up the name and the age using, like I said, the superclass constructor. And then down here, I'm setting the country of origin, which is the attribute that I added in the Italian chef class. So this is pretty common, and it's a pretty common use case with inheritance. And then so down here, you'll notice that I have my chef object, and I just passed in Gordon Ramsay and 50, so the chef's name and age. And down here I have my Italian chef object, passed in a name and age, and then also the country of origin, which in our case for this chef is going to be Italy. And then down here I printed out my Italian chef.age just to kind of prove that everything worked. So you see over here we're printing out 55. And so that's how you can essentially override the superclass constructor in the subclass, and then you can also call the superclass constructor for example, to initialize name and age. All right, I want to show you guys one more thing with inheritance, which is abstract attributes. So actually in C++, we call them virtual attributes. But the basic idea is that you can define attributes or functions which are virtual, which basically means that the superclass isn't going to define them. It's going to be up to the subclasses to define them. So essentially everything has to be overwritten by the subclasses. So down here I have this vehicle class, and inside the public block, I have virtual void move. So I'm defining essentially just a function stub, but I'm saying that it's virtual, which means that any classes that inherit this move function need to implement it, and I'm setting it equal to 0. And this is basically how you could set up like a virtual function. And then down here, I have just a normal function which could get inherited. This isn't virtual. So down here, I have subclasses. I have a bicycle subclass and a plane subclass. So the bicycle subclass you'll see is implementing this move function that was defined up here. So it's implementing it on its own, and then the plane subclass is doing the same thing. So it's implementing that move function. And in order for these to be valid subclasses of vehicle, they need to implement the move function. That's what that virtual keyword is specifying. So down here you see I'm creating a plane object, and then I'm saying myPlane.move and then myPlane.getDescription. So when it says myPlane.move, it's the plane flies through the sky. But when it says myPlane.getDescription, it just says vehicles are used for transportation, which is what was defined up here inside of this get description function. So that's how we can use virtuals. Like I said, in other languages, a lot of times people will call these abstract functions, but that's how we can do it in C++. So that is sort of a basic overview of a lot of the core, things that you want to do in C++. Obviously, I didn't cover everything, but hopefully this gives you a good idea of the syntax of C++, kind of how things work, some of the best practices, and kind of gets your foot into the door and gets you a little bit more comfortable, takes some of the mystery away from the C++ programming language. Again, I will just say one note on this, which is because C++ is technically like it was forked from a pre-standardized version of C. A lot of times what developers will do is they'll use C and C++ interchangeably inside of their C++ programs. And one of the things you want to do is make sure that when you're using C++, you actually need it and you're using everything for the language, because otherwise you just want to use the C programming language. Like what you don't want is some bastardized program that has C and C++ and it's kind of not doing things in a C++ manner, but also not doing things in a C manner. Like you want to make sure that if you're using C++, that you're using C++ and you're not just using C inside of your C++ program. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.